Welcome, this is Algebra 2, Unit 310. How do you find zeros in polynomials? Okay, you've already kind of done this. This is almost a review lesson because in 311, good chance that 311 will actually end up being your quiz over this unit. You're going to be doing some problem solving on teams as far as figuring out how zeros can correlate to a situation in life. Okay, so just use this as a nice review. Here's one situation where you might be looking to find zeros, and you'll notice, or hopefully you notice, the pattern. And that should look familiar. It's symmetrical in the coefficients, and you should be thinking Pascal's triangle. It is. The coefficients do match the third row of Pascal's triangle. You can take this last number to figure out what this is. Since it is third row, you can take the cube root of 1, get positive 1, and you know that it's x plus 1 to the third power. So the zeros here would be -1 3 times. So that means on the graph it's going to pass through that -1, okay, because it's an odd number there, right? Next one. If you get into a situation where there isn't a pattern, then I want you to think about what are the possible zeros. And remember, you take the factors of your constant. Factors for 2 would be 1 and 2, positive or -1, positive or -2. And that's over top of your factors for the leading coefficient, which is 1. I really like it when we have a 1 there. I'll try to do that for you so that these don't get too cumbersome. Okay, so our next thing is to divide and find the zeros. Like I told you in the video when I taught this, I always choose 1. That's my first one just because it's nice and easy. Now you do need to check. These go down 3, 2, 1, 0. So I just pull my coefficients, 1, -1. Get that from right there. -2 and +2. Synthetic division, I drop the 1. 1 times 1 is 1. Add these two, 1 and -1 is 0. 1 times 0 is 0. -2 plus 0 is -2. 1 times -2 is -2. With a 0 in the last column, bingo, we know that that is a 0. That 1 is a 0. So there's one of my zeros, is at 1. Now that means that the factor is actually x minus 1, just in case you're getting confused with that. So one of the zeros is at +1 going up the graph. It would cut through at +1. Now we come down and we say this was a cubic function, so this is a squared function. That would be the x, and that would be -2. So we have x squared minus 2. Since you don't have a middle term, you don't need to worry about trying to factor with that. You can actually just set it to 0 and find your other zeros. Add 2 to each side, so you'd have x squared equals 2. Final step would be x equals plus or minus radical 2. So we have the zeros are plus minus radical 2. You could put your factor in there as x squared minus 2. Okay, and those are your your three zeros. You should have the same number of zeros as you do the leading exponent, the degree of the polynomials. So that's 3 of those. Okay. Next one might come in a polynomial that you could easily factor. This, you should see it as a difference of 2 squares. Thinking about a difference of 2 squares should tell you, hey, I factored this as conjugates because I'm wiping out my middle terms. So the square root of x to the 4th is x squared. Square root of 16 is 4. Now if you look, that's another perfect square, so I write it again, x squared plus 4. And then this would be conjugates again. X minus 2, x plus 2. So in solving those, the value for x would be x would equal 2 here, and the x would equal negative 2 here. Go ahead and set them to 0 if you need to do that. On this one, I just want to step through setting it to 0. I would subtract 4 from each side. And so I get x squared equals negative 4. In doing that, I take the square root plus or minus, so I get x equals plus or minus square root of 4 is 2, and because it has a negative, I've got to bring out an I, so I've got 2 imaginary. So I have plus or minus 2i. So I've got 2 zeros there, a third one there, a fourth one there. 4 zeros is what I should have. Okay? So the number of zeros should equal the degree of the polynomial. And this will work as long as the repeated zeros count multiple times. Like in the first one, when we had x plus 1 raised to the third power, it had to count 3 times, even though you see on the graph it only crosses once. You also have to count irrational zeros, and you have to count imaginary zeros. The imaginary zeros are not going to show on your real number system graph, but you still have to count them when you're looking at factors. So I wrote each of these 3 examples down. You can copy it into your notes, and you can ask questions on it, but this is what I'm explaining. When it's multiple times, you have to count it that multiple times to get the 3. Even though on the graph it looks just as 1, because it's only going through there once. When you have an even, remember it goes tangent to it, and so you would see this one has 3 times, and on the graph you'd see it go through the negative 1 and then, through a positive 1 and then do a tangent on the positive 2. This one would go through at negative 1. And then on this one, you would have it with the 2i and negative 2 and positive 2. So you have to count the imaginary ones as such as well. Okay, so enjoy. Come ask questions as you need.